Good morning, students. Today I will teach you about the Boolean algebra and minimization techniques. Let's first take the chapter objectives. Understand the concept of Boolean algebra. Understand the logic operations available in Boolean algebra. Understand the basic law of the Boolean algebra. Understand the De Morgan's theorem and K-map technique. Way back, mathematician George Boole defined the Boolean algebra as a technique which provides the rules for carrying out the logical operations. The logic operations available in Boolean algebra can be categorized as logical AND operation, which is given like y is equal to a dot b for two different Boolean variables a and b. The value of AND operation for different values of a and b are like that. If a is 0, b is 0, then a dot b is also 0. If a is equal to 1, b is equal to 0, then a dot b is also 0. Similarly, if a is 0, b is 1, then a dot b is 0, and a is equal to 1, b is equal to 1, then a dot b is equal to 1. Which means, when we talk in the terms of the electrical signals, if suppose there is any AND operation gate of the circuit representing the AND gate operation, digital circuit, then there are two kinds of input possible to that particular circuit and one output. And both input will be either logical input, either both 0 means both are connected to the ground, or if it is 1, then it is connected to the VCC 5 volt DC supply. Output Y can be measured through its application. Suppose Y is given as input into a digital circuit of LED. If it is representing 1, that is 5 volt display, then LED might glow. Otherwise, if it is 0, then LED may not glow, a circuit is not complete. Another logical operation, OR operation, what is represented by y is equal to a plus b. The OR operations for different values in a and b are like that. If a is 0, b is 0, then a plus b, that is OR operation of a and b is equal to 0. इसी तरह से अगर a is equal to 1 and b की वैल्यू 0 है, तो a प्लस b की वैल्यू 1 होगी, क्योंकि और का मतलब होता है कि दोनों a या b में से कोई भी इनपुट अवेलेबल है तो आउटपुट पे हमें 1 अवेलेबल होगा, जिसको हम 5 वोल्ट डीसी सप्लाई और ग्राउंड से भी कंपेयर कर सकते हैं. यानी कि अगर एक एंड पे और गेट के हम या सर्किट जो है डिजिटल सर्किट है जिसका अगर हम बोलें कि 5 वोल्ट डीसी सप्लाई है तो आउटपुट पर हमें 5 वोल्ट डीसी मिलेगी. Okay, then a is equal to 0, b is equal to 1, a plus b is 1. Similarly, if a is 1, b is 1, then a plus b is also 1, because a b1, it doesn't mean that it is multiplied by, the supply will become double. No, it means that only both the input are having the supply, then output will definitely have that supply 5 volt DC. Next is the logical complement operation. It is categorized by the NOT operation. It converts logical 1 into 0 and logical 0 into 1. That is, if a Boolean variable, then complement of a is represented by a star or a dash या a bar. Alternatively, bar over the variable is also used to represent the complement of the variable. That is, whatever be the given as input, it will be out in the output. We will receive the logically complemented output of that input. Now we talk about the basic law of the Boolean algebra. The basic law of the Boolean algebra are used to provide the mathematical expressions for logical operations. The Boolean rules define only two variables, binary 1 and 0. The basic rule of Boolean algebra can be categorized as Boolean addition. Addition means adding the two Boolean variables. 0 plus 0 is equal to 0. 0 plus 1 means it is OR operation 1. 1 plus 0 is 1. 1 plus 1 is also 1. And that is available. We can have say that we have signal available at the output. Similarly, on multiplication laws, 0.0 is 0, 0.1 is 0, and 1.0 is 0, and 1.1 is this, both the input are available and output will have availability of the signal. It is according to the AND gate operation. The properties of Boolean algebra depend on the binary operations denoted by plus symbol and dot symbol. Similarly, the operator denoted by either bar symbol is the inverter operation of that particular input. We can have various laws or properties associated with the Boolean algebra. One is the commutative property. It represents then if a Boolean addition is a commutative, that is a plus b is equal to b plus a. Similarly, Boolean multiplication is also commutative, a dot b is equal to b dot a. It is order of Boolean operation conducted on the variables makes no difference on the result. associative law. It represents that if Boolean addition is associative, then A plus B and C into the bracket is equal to A plus B plus C. Similarly, Boolean multiplication is also associative, that is A dot B dot C is equal to A dot B dot C. That is, it is conducted on several levels, provided same result irrespective of their grouping. Now we talk about the distributive property. Distributive law क्या बोलता है कि अगर A plus BC है तो उसको हम A plus B dot A plus C की फॉर्म में लिख सकते हैं. इसी तरह से अगर A डॉट B प्लस C ब्रैकेट में है तो उसको हम A डॉट B प्लस A डॉट C में डिस्ट्रीब्यूट करके लिख सकते हैं. तो Boolean addition is distributed over the multiplication. Similarly, Boolean multiplication is distributed over the Boolean addition. De Morgan's theorem. De Morgan gave the two theorems. That is, if we have AND operation between two variables and we complement of that, then we can say that it is equivalent to individual inverted or complemented variables and between the addition between them. That is, complement of ANDing is equal to ORing of complements. Similarly, Boolean gave the second theorem of De Morgan's second theorem, that is, complement of sum of two binary values is equal to the product of complement of two binary values. That is, complementive of ORing is equal to ANDing of complements, that is, A plus B bar is equal to A bar dot B bar. Now we talk of the two terms, that is sum of products and product of sum. These are the logical variables for expression. Sum of products means expression y, if it is written as AB plus BC plus AC, that is, it is sum of three product terms, that is AB plus BC plus AC. Similarly, product of sum is equal to, we have y, which is a product term obtained from the sum of individual operations like sum terms, that is A plus B multiplied by bracket में B plus C multiplied by A plus C. Last but not the least, we talk about the K-map technique. It is also one of the techniques we use to simplify a Boolean expression, logical expression, and thus to minimize the expression, and so that the number of gates required for application or implementation of the circuit are also reduced.